In this video, we're going to be talking about rewriting some equations into a quadratic or into another quadratic by substitution, okay, by letting maybe a equals to something or y equals to something to make it easier to solve. If we have to break all the brackets and form it into a general form, it will take a lot of time. Now, if you look closely, the setup of this equation already tells us that it is in some other form of quadratic. If I take star to be this thing inside the bracket. So in this case, let star be this thing, okay? And so now this gives us a very simple quadratic to solve. By factorizing, I've got star equals to 4 or negative 2. So now I could put this back in here in terms of x and get these two answers. By doing this kind of substitution, we have saved a lot of time compared to expanding the brackets. Now in these two questions, these are not quadratics, but it could be reduced into quadratics. Now the task is to recognize what the star is. Now for part B, you see that x to the power of 4 is actually square of this, right? Then maybe we could start from here. Then because of this, we've got a new quadratic which looks pretty good, which gives us these two values of stars, and then we put them back in for star. Now here's the trick, because a square cannot be negative, never, right? So this one has to be rejected, and so this gives us these answers. So be careful, we may have to reject some answers, in this case like that. So for part C, because recognizing this, okay, we do the same substitution here. So we start out with this, then we switch the signs for everyone here because we want the a to be positive. So in this case, star equals to 25 or 4, nothing to reject. You have actually 4 solutions, 4 answers, 4 roots. For this example, even when we have surds, it still works, because in this case, we could actually let square root of x be the star. And so by doing this, we still have a handsome quadratic here. And by factorizing, we've got star equals to 9 or negative 4. And in this time, when we put this back into the equation, this one case has to be rejected because after square rooting, we cannot get anything negative. And so in this case, there's only one answer, 81. Even for this kind of questions, it still works, because you could recognize that x to the 4 over 5th is actually equals to 2 over 5th whole square, right? And so if I do that, I get a nice quadratic, and that leads us to here. But in this case, this one should be rejected because it's given that x must be greater than 0, and therefore x to the 2 over 5th power must also be greater than 0. So if we continue here, we apply 5 over 2 on both sides so that we could cancel out this power here. But we know that 4 is actually 2 square, right? And so x plus equals to 32. Now, speaking of rejecting some answers, okay, I could give you some examples. So for example, a square cannot be negative, and a square root cannot be negative. And actually, if in this case, if the denominator is even number, it's also rejected. And this is just a particular case of this, because square of x is just x to the power of 1 over 2. But if this is odd number, it may be okay. This is an example that is okay when this is a odd number. And when I have a positive number to any power, will never give a negative answer. And also when you're checking answers and you put the answer into original question and you found out that denominator is equal to 0, then of course you have to reject that. And finally, when you've got your answer x equals to 4 and you plug this back into the original question, when you have log of something, but your something inside this cannot be less than 0, then you have to reject it. Consider the graph of y equals to log x. Your domain is always positive, like that. So after all, always after you've done, put your answers back into the original question to check if it's reasonable, and look clearly for any condition specified on the question for the answer.